So today we're going to look at the last lesson in Unit 2, which is 2-6. It's over linear programming. So the definition of linear programming is a method which uses linear equations and inequalities to determine the optimal solution to a certain situation. Let's see.
Miss Murray. Hey.
How are you doing?
We're taking soccer pictures.
Oh, you are? Sorry about that. I was saying hi to a former student. All right, so let's look at the procedures that you're going to use to do what's called linear programming. So essentially, we're going to look at a real-world situation. Typically, it deals with a business that's producing something. And we tend to maximize profits, or we could minimize costs. So it's a real world application. It kind of culminates everything that we've done in Unit 2 into one great big word problem. So don't get overwhelmed, but we're going to read the word problem. We're going to pull out things that are important. So I want you to highlight things that are important, things that could constrain. So if I have a business, I can't just make oodles and oodles of my item and get it out there, because there are things that are naturally going to constrain me, like materials. I might only have a certain amount of materials to use, and so I can't make every gadget that I have orders for, because I might not be able to get enough materials, or there might not be enough time in the day for me to be able to constantly be manufacturing items to fill my orders. So there's all kinds of things that can constrain a situation. And then there's going to be things that we're going to look for what we're maximizing. So if I'm maximizing profit, look for things that tell me how to find my profit. So as we go through this problem, we're going to highlight as we go. And so let me move it up just a little bit more so I can write on it on my laptop here. Okay, so the smallest plane in the coast-to-coast airlines fleet offers first class and tourist class seats and can hold a maximum of 50 passengers. So that right there sounds like a constraint, meaning I can't, if I have 60 passengers on my plane and there's only 50 seats, I don't have enough of those 10. I'm not going to be able to put those on the plane. So I'm going to highlight that. So I've got a maximum of 50 passengers. Then, in order to charter a flight, the airline must sell at least 8 first class tickets and at least 20 tourist class tickets. So again, that sounds like a constraint in the sense that I have to have at least this many in order for that airplane to take off. So I must sell at least 8 first class and at least 20 tourist class tickets. So those are all constraints. Then it goes on to say the company makes $40 profit for each first class ticket and $30 profit for each tourist class ticket sold. In order for the company to maximize its profits, so here I actually find out what I'm maximizing. So I'm maximizing profits. So they gave you some information about profits. $40 for each first class ticket and $30 profit for each tourist class ticket. That's how we're going to find our profit. In order for the company to maximize its profits on a single flight, and here's the question, how many first class and tourist class tickets should they sell? So we have to define our variables. What is it that we don't know? If we're trying to find out, always go to the question, how many first class and tourist class tickets should they sell? That's what I'm going to define my variable as. So I'm going to start, before I do constraints, and define my variables. So I am going to let x equal number of first class seats or tickets, however you want to write it. And then I'm going to let y equal the number of tourist tickets or tourist seats. That's the same as coach. Now, technically, you could reverse your x and y. So your y could be my x, and your x could be my y, because the first class does not depend upon tourist seats, and tourist seats does not depend upon first class. So it really doesn't matter. Our graphs might be slightly different looking, but we're going to eventually get the same answer. So then let's write our constraints. So the first constraint says that we have to have a maximum of 50 passengers. So that means that the number of first class seats and the number of tourist seats cannot exceed or go over 50. So I've got x plus y has to be less than or equal to 50. So that's one constraint. Then they also went on to say that you must sell at least 8 first-class tickets. So these need to be greater than or equal to 8. So that's another constraint. So x has to be greater than or equal to 8. At least means you're going to get a minimum of 8 or more. Then we have to sell at least 20 tourist class tickets. So the y needs to be at least 20 or more. So that's going to be greater than again. So y is greater than or equal to 20. So we are going to graph those, but before we graph them, let's go ahead and write our objective function. So our objective is to maximize profit, so that is where our objective function comes into play. So since we're maximizing profits, we get $40 for each first class and $30 for each tourist. So I'm going to write my objective function here. So profit equals $40 times every first class ticket plus $30 times every tourist class ticket. We are not going to graph the objective function. The objective function is purely for us to determine what combination of seats is going to maximize my profit. So we'll come back to this. Let's graph these. So right now, this is not in any kind of form to graph. I have to have it in slope-intercept form, so I have to solve for y. So to solve for y, I'm going to subtract x and subtract x. So that gives me the following equation. I'll write it in green. So I get y is less than or equal, that's a less than, negative x, and then plus 50. So I have to graph this, this, and this. So I kind of have to determine what my increments are going to be over here. So if you count all the way over here, you're going to count 22, and you're going to count 22 up here. So I only have 22 grid lines. Clearly, I'm not going to be able to go by ones because my y-intercept here is 50. I could get the 8 and the 20 on there, but I'm not going to be able to fit the 50. So I could go by twos. No, I couldn't go by twos because 22 times 2 is 44. I'm still not going to fit the 50 on there. So the problem's going to arise. I don't have any multiples that are reasonable that involve 8 with these two. So the best bet that I'm going to do is I'm going to go by 5s. So this is going to be 5, 10, 15, 20, and so forth. So my increments are by 5s, but I'm going to only label every other one because it gets too much if I label every one. So this is going to be 10, and then this is going to be 20. So again, I'm not going by tens, I'm going by fives. It looks like I'm going by tens because I'm labeling every other increment. And then 60 should be good enough. And I'm going to label the x-axis. That's 10. So I'm going by fives here as well. Okay. Then we need to label what's going on the x-axis and what's going on the y-axis. So we already said our x-axis was number of first class seats. Then, let me move this to the side. I'm going to get over here number of tourist. Well, that should be an I, tourist seats. So label your x and y axis so that the readers know what's on what. Then let's go ahead and graph it. So I'm going to graph the green line, y is less than or equal to negative x plus 50. I'm going to graph that, so my y-intercept is 50, and my slope is negative 1 over 1. So I'm going to go down 1 to the right 1, down 1 to the right 1. Keep plotting. All right, so then I am going to connect this with a straight line. Okay. All right, then next I'm going to graph x is greater than, whoops, looking at my notes. Then I'm going to graph x is greater than or equal to 8. Now remember, if you're missing a variable, this is the same as graphing x equals 8 and same as graphing y equals 20. So if you're missing a variable term, x or y, you either have a vertical or horizontal line. You know what axis it goes through by what variable you have. So x equals 8, you're going to plot 8 on the x-axis. The problem is we've gone by fives. So if this is 5 and this is 10, 8 is somewhere here in between. So it's going to cause a little bit of a problem when we find our vertices, but we'll reason our way through it. So I'm going to plot, I'm going to make this blue, maybe I'll make it red. I'll put it in red. So I'm going to put, I don't know, 8 right about there. Yep, that's close enough. Then I'm going to connect. The only way to go through the x-axis is to do a vertical line. So, totally missed it because now it's on 10. Let me see if I can move it over a little bit. There we go. Okay. So let's talk about the shading before I do the last line. Notice that I didn't shade anything, and there's a reason for that because it's going to get kind of overwhelming. So this equation right here was less than. So here's my line. Less than this line is all of this right here. Now, as you notice, we are in quadrant 1 only. We don't have 4 quadrants. And the reason for that is, think about it. If this is tourist class seats, could I have negative tour class seats? No. And if, or this is first class. And if this is tour class seats, I can't have negative of those either. So oftentimes when we're in the real world, we are stuck in the first quadrant because those are your positive numbers. So your x and y axis act as additional constraints. So for right now, this is all the shaded region for this one. Then x is greater than or equal to 8, all of this is going to be shaded. So the shading that they have in common right now is this triangle shape right here. Okay, so let's do the last one. Y is greater than or equal to 20. So we need to put a point on the y-axis at 20. So I'm going to put a point right here at 20 and then connect them with a line. Now this one is greater than as well. So here's the shading here would be in this direction. Remember, the shading for the red is over here and the shading for the green is here. So this triangle right here is the only shading that they have in common. So we need to find what's called the feasible region. So I'm going to shade that feasible region in with yellow highlighter, and you should do the same. So that's my feasible region right there. So for this first one, we're going to put here an arrow saying that this is the feasible region. I won't do this normally, but for your notes, we'll put that in there because that's the part that's important. Any ordered pair in this intersection of shadings for all three of these inequalities, any of these ordered pairs would meet these constraints, and so anything in here we can use. Now, in order to maximize our profit, we need to focus on the vertices creating this feasible region. So we have to find the ordered pairs to those vertices. So here's one, here's the second one, and here's the third one. So for our vertices, we need to test them. So we've got 3 different vertices, and we have to test all 3. So we're going to set up a table of values down here. So we're going to have an XY, and then we're going to use our profit, our objective function profit. We're going to plug in each of these X and Y values into this profit function to see which one's going to maximize our values. So I'm going to put here 40x plus 30y, and it is going to give us our profit. So let's find our 3 vertices. One of them is going to be a little challenging. So this one's not so bad because I know that its x value right here is 8. So the x value is 8 and the y value is 20. So I have 8, 20. Then this is the ordered pair right here. This one's going to be tough because it looks like, remember I'm going by 5s, it looks like that's at 45. But I know the x value is at 8, but it looks like that's at 45. I know that that can't be because remember, my seats cannot exceed 50. So if this is 8, and I know that for sure, that can't be 45. So it has to be somewhere between 40 and 45. And so my guess is that I've got 8 already, right? So 8 for the first class. So that leaves 42 more seats out of 50. It's possible that that's a 42 and that my line's just a little off. See how my green line's off a little bit there? So truly, and this is what it would have been helpful if we could have gone by 1s, then I wouldn't have to be guessing. So the second order pair is 8, 42. And then my third order pair is over here, and that one's a definite. I know that my x value is 30 and my y value is 20. So we're going to test 30, 20. So then I'm going to get ready to substitute in. So I'm going to use parentheses. Okay, so now I'm ready to substitute in my x and y's. So for my first order pair, my x is 8 and my y is 20. My second order pair, my x is 8, and we decided that our y had to be 42. And for the third, my x is 30 and my y is 20. Question is, do I have to show all 3? Yes, even if you definitely for sure know what the maximum is going to be. Then at this point, use your calculator. So 40 times 8 plus 30 times 20. You're going to throw that in your calculator. So tell me what you get. You should get 920. And then the next one, 40 times 8 plus 30 times 42. So you should get 1580. And the last one, 40 times 30 and 30 times 20. You should get 1800. So out of those 3, I think we would all agree that this is the maximum amount of profit. So then you have to answer the question. Oh boy, we're starting that again. All right, so I'm not going to be able to move anything. So you have to answer the question in a complete sentence. And you have to explain what it is that this is telling the people. So you remember we've got airline tickets. So we're going to maximize, that airline is going to maximize their profit at $1,800 if they sell, remember X is your first class, so if they sell 30 first class tickets and 20 tourist class tickets. So we have to write that in an actual sentence. So here we go. And you could say, therefore, ... the airline will maximize, and I'll let you put max for maximize, their profit at $1,800, dollar signs go in front of the number in the United States, if they sell 30 first class and 20 tourist class tickets. That's all there is to it. So let's do another problem. All right, so let's look at example 2 and make this slightly bigger. Okay, so as you read example 2, you are looking to highlight things that would be constraints, things that would work towards maximizing profit, because they want to know what should she do to maximize her income. So I want you to pause the video and I want you to read through and highlight the problem and try to figure out what are your 2 constraints. So make sure you define your variables first and then find your constraints. So pause the video. All right, so hopefully at this point you have paused the video. And so let's go ahead and read the problem. So as we read the problem, we have Natalie's a hairstylist. When making appointments for her clients, she allots 30 minutes for each cut and 2 hours for each cut and color. So I'm going to assume, well, those are restrictions or those are constraints because she allots a certain amount of minutes. So I am going to highlight that she allots 30 minutes for each cut and 2 hours for each cut and color. Okay, then we go on to read. She has 10 hours available for appointments, so that's another constraint. 10 hours available for appointments. Then each day, and she prefers to see no more than 8 total clients, so that sounds like another constraint. Actually, I'm going to erase this in blue because if she allots 30 minutes for each cut and 2 hours for each cut and color, and then she only has 10 hours available total, those constraints are going to go together because they all deal with time. The next constraint, where she wants to see no more than 8 total clients, that is a constraint, but it does not have to do with time. It has to do with number of clients. Each routine cut costs $40 and each cut and color costs $100. How many of each type of appointment? So that's the question. How many of each type of appointment should she schedule? So that's what you should let your variables be, because that's what the question's asking. That's what you don't know, to maximize her income. So anything to do with her income will be part of the objective function. So let's go back and reread. A routine cut costs $40 and a color costs $100. So that must be part of maximizing her income. So routine cut costs $40 and a cut and color costs $100, and we want to maximize her income. All right, so here we go. Hopefully you identified your variables as such. So whoops, we don't want the big fat pen. Let's try this again. Hopefully you identified X as number of cuts. It's not time, it's number of cuts or number of appointments for cuts. And then Y is your number of cut / color. All right, so based upon our constraints, let's go with the easy one first. The easy one is that she can have no more than 8 total clients. So the X plus Y has to be less than or equal to 8. Then the problem with the time is she has 30 minutes for a cut and 2 hours for cut and color, and she's got 10 hours total. Well, you got 30 minutes and hours. So you have to have everything in minutes or everything in hours. So let's convert everything to minutes. If you convert it to hours, you're going to get the same answer when we go to graph it anyway. But we start with 30 minutes. So for every one of these cuts, it uses up 30 minutes. So we're going to, for our constraint, we've got 30 minutes times each cut. We're going to add to that the number of minutes for a cut and color. Well, if it's 2 hours for a cut and color, each hour is 60 minutes. So 60 times 2 is 120. So we have 120 minutes times every cut color has to be less than or equal to, because she doesn't have any more time available, we've got 10 hours. So 10 hours times 60 minutes per hour is going to be 600 minutes. So 600. Don't be afraid of the big numbers. You've got a calculator. So then let's go ahead and solve this both of these equations for Y. So if I take this first equation here and solve it for Y, we're going to subtract X from both sides. So if I subtract X from both sides, this is going to end up giving me Y is less than or equal to negative X plus 8. We'll graph that in a minute. Then for the second one, to solve for Y, I need to get that by itself, so I'm going to subtract 30X. I get 120Y less than or equal to negative 30X plus 600. Then to solve for Y, we have to divide everything by 120. Remember, you can throw that into your calculator and hit math, enter, enter if you get a fraction. And so you get Y is less than or equal to negative 1 over 4 X plus 5. So I am going to graph this one in green. All right, so let's figure out our increments. Since my y-intercept here is 5 and my y-intercept here is 8, I can definitely go by ones. So there's no need for me to label my increments because I'm going by ones, but I do need to label my x and y axis. So my x-axis is number of cuts, and my y-axis is number of cuts, cut colors. Okay. So for the red line, I'm going to start at 8. And then my slope is negative 1, so down 1 to the right 1. And then I'm going to connect that with a solid line. And then it's less than, so my shading would be down here. And again, these are natural restraints because we can't have negative cuts in color. So then the green line starts at 5. And we have a slope of negative 1 over 4, so down 1 to the right 4. Okay, so then I'm going to connect that with a straight line. There we go. And then that one is less than as well. So if this is less than and this is less than, then this right here is going to be our feasible region. So we are going to highlight that, color it in. Okay. And now we're going to find our vertices. So I have a vertex here, 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 and here. So we did not write our objective function yet, so let's go ahead and write that. So it says each routine, so we've got income. Income equals. So she makes $40 on a cut, and that's our X value, so 40 times X plus, and she makes $100 on a cut and color, so that's 100 times the number of cut and colors. So then we need to set up that table where we're going to evaluate our vertices. And so I've got 40x plus 100y is going to become income. See if I can squeeze 4 vertices in here. That's going to be a trick. All right, so my first vertex is right here, 0, 0. I'm probably going to run into example 3 because I'm not doing example 3 anyway because this video is long enough without that. All right, so then our next vertex is here, and that X value is 0, Y value is 5. So 0, 5. And then our next vertex is here, and so that X value is 4, Y value 4. So we have 4, 4. So I'll put that down way down here. And then our last vertex is here, and that is at it should be at 8, right? 8, 0, and that makes sense. So let's put 8, 0. Okay. Then I'm going to prepare to substitute in, so I'm going to put in my parentheses. All right, so sub in your X and Y, so 0, 0, 0, 5, 4 and 4, and 8 and 0. Okay, so then let's throw this into our calculator and we will find our income. So clearly 0, 0 is going to give us no income. If she's not going to cut anybody's hair, she's not going to make any money. Then for 0, 5, she's going to end up with $500. Not bad. That's in one day. And then for 4, 4, she ends up with $560. And then for 8, 0, she's going to end up with $320. So if you thought that she would maximize her income by doing nothing but cuts and colors, because that's where she makes most of her money, well, she can't do that because she only has enough time for 5 clients because of her time constraint of 10 hours. She doesn't want to work more than a 10-hour day. So because of that, if all she did was cut and color, she'd only make $500 a day. But if she mixes it up a little bit and does a few cuts and a few cuts and colors, she's actually going to make $60 more than she would if she just did all cuts and color. And so she mixed it up and did half and half, and she's going to end up maximizing her profit at $560. So let's go ahead and write our answer, because this is our max. And then we're going to write our solution. So therefore, Natalie will maximize, we're just going to put max, her income at $560. I don't have room to put per day in here, but it is per day. If she does 4 cuts and 4 cut and colors. And that's it. So you have a choice board of 6 problems, 6 linear programming problems to do, and you only need to choose 2 of them out of those 6. So decide which 2 you feel most comfortable with and complete those. And if you have any questions, please don't hesitate to text me. Have a great evening.